Welcome to This Explainer. I am so incredibly thrilled to have you here today. Look, if you've ever written software that worked absolutely perfectly on your own machine, only to literally fall apart the exact second a real person touched it, well, you are in the right place. Today, we're stepping into the high-stakes world of building truly reliable and super efficient Java software. We're going to dive into two foundational pillars from our source material that absolutely separate amateur code from professional-grade systems: exception handling and multithreading. Let's get into it. So to kick things off, let me ask you this. What actually happens when a user tries to order -10 items from your inventory? I mean, we can laugh about it, but you know as well as I do, users will inevitably try to do the impossible. They'll type letters into phone number fields, they'll upload gigantic files where tiny little icons should go, and yep, they'll try to order negative quantities. And when they do, it leads straight to our main problem: crashing applications. Okay, let's dive right into this roadmap. 1. Preventing application crashes. 2. Mastering exception handling. 3. Real-world inventory validation. 4. Multitasking with multithreading. 5. Real-world concurrent operations. And 6. The resilient developer.
Section 1. Preventing application crashes.
Think of me as your senior developer mentoring you through the messy reality of production code. The biggest nightmare you're going to face out in the wild is bad data. A single invalid input can literally bring an entire system down. This is the core issue our source material tackles regarding the proper functioning of applications. The stakes here are incredibly high. An unhandled error doesn't just show an ugly red message to one user, it stops the whole application dead in its tracks. It freezes processes, drops connections, and just creates a generally terrible user experience. We absolutely need a way to build a protective shield around our logic.
Section 2. Mastering exception handling.
And that brings us to our first real hero of this explainer: exception handling. The source material defines this beautifully. It's a mechanism to check and handle the proper functioning of applications when unexpected events or errors occur. The whole goal here is to give you the exact skills to maintain that proper functioning. When that totally unexpected event hits, like our buddy ordering -10 items, exception handling is the safety net that catches the error before it takes down the whole system. Now, what's really interesting about this is our actual toolkit. We've got the big 5 keywords: try, catch, finally, throw, and throws. But the source material also points out that we can use multiple try and catch blocks to handle different types of errors in totally unique ways. We can even create user-defined exceptions to handle very specific business logic that standard Java simply doesn't know about. So this isn't just theory, right? This is literally your complete practical arsenal for writing unbreakable code. Let's walk through the actual logical flow of these main keywords. It works a bit like this. Step 1, you try to execute your risky code. You just wrap the potentially dangerous operation right inside a try block. Step 2, if things go sideways, you catch the error. This is where you handle it gracefully instead of just letting the app die. And then step 3, finally. The finally block executes cleanup code no matter what happened. Actually, whether the code succeeded or completely failed, that finally block runs, making sure you don't leave things like open database connections just hanging around. It's a really elegant, foolproof sequence.
Section 3. Real-world inventory validation.
And this brilliantly illustrates the night and day difference of using these tools, specifically looking at a scenario called Task 10 from the source material. On one side, without exception handling, a negative price or an invalid product ID simply bankrupts the system. It throws an unhandled error and the program halts. Just boom, system crash. But on the flip side, with exception handling, that exact same bad data is safely intercepted. The system basically says, hold on, that's an invalid product ID, or hey, you can't have negative stock, and it just continues running safely. Let's look at the specifics of Task 10. It requires developing a Java program to validate inventory data. You're tasked with explicitly handling 3 major business errors: an invalid product ID, a negative price, and a negative stock quantity. And you have to do this using that entire toolkit we just talked about: try, catch, finally, throw, and throws. So if a user inputs a negative price, your code will literally throw a custom exception, your catch block will grab it right out of the air, and your application will stay perfectly alive to ask the user for a valid input. Which brings us to Learning Objective 4.1, a major takeaway here. Applying exception handling techniques isn't just an exercise in learning syntax. It fundamentally improves the reliability of inventory management applications. Reliability is absolutely the key word here. It means your software can be trusted to run around the clock, keeping the business data and the user experience totally safe. Section 4.
multitasking with multithreading. Okay, so now that we've secured the reliability of our app, we need to talk about beating the performance bottleneck. Think about the number 1. This represents a single thread. Traditional programming often relies on a single thread trying to do absolutely everything one step at a time. Imagine a single worker in a massive warehouse trying to process payments, update the inventory, and write daily reports all sequentially. What happens? Well, your application sluggishly freezes up, just waiting for one task to finish before it can even start the next. To solve this bottleneck, we introduce our second hero concept, multithreading. The material defines it as a concept applied for multitasking, allowing multiple threads to execute concurrently. Think of it like cloning that single warehouse worker so you now have an entire team working at the exact same time. It basically allows your application to do 2, 3, or even 100 things at once. It's a total game changer. To actually master multithreading, the source outlines the core contents you need to know. You've got to understand the thread lifecycle, how a thread is born, runs, and eventually dies. You need to know the thread class methods to manage them, and absolutely crucially, you need to know the 2 primary ways of creating threads in Java, using the extends keyword on the thread class or using the implements keyword with the runnable interface. These are your foundational tools to spawn and manage all these simultaneous tasks. Let's move to Section 5, Real-World Concurrent Operations. Let's see how this builds into the practical application from Task 11 of our source material. Imagine exactly how this functions concurrently. We have thread A, right? And it's dedicated solely to updating product stock. While that's happening, literally side by side, we have thread B, which is generating a huge data-rich inventory report. Because of multithreading, neither task has to wait for the other. Thread A is handling real-time operations, and thread B is just crunching data in the background. It is a beautiful orchestration of concurrent execution. And this perfectly ties back to Learning Objective 4.2. Multithreading enhances the efficiency and responsiveness of inventory management applications. Efficiency and responsiveness are the ultimate rewards here. Your software doesn't just work safely now, it works blazingly fast, keeping the user engaged without those dreaded loading screens freezing up the app. Section 6. The resilient developer. So the crucial point is this. We've covered the theory and the real-world applications. Let's bring it all together. Mastering Java really isn't just about memorizing a few commands. It's about balancing 2 powerful forces. On one side, we have exception handling, giving us reliability and safety. It shields your system from bad data and those random, unexpected errors. On the other side, we have multithreading, delivering efficiency and responsiveness, letting your apps scale and multitask like a pro. Mastering both of these equips you to build robust systems that won't crash and burn, while still performing incredibly well. I want to leave you with this final thought. It's pretty easy to write code that works when absolutely everything goes perfectly. But ask yourself, your code works, but is it truly resilient enough for the real world? Because the real world is messy, it's concurrent, and it is full of invalid inputs. By internalizing these core concepts, exception handling and multithreading, you are now fully armed and ready to tackle those challenges head-on. I hope you're excited to apply these learning objectives to your next big project. Keep learning, keep building, and thank you so much for hanging out with me on this explainer.